Thought I'd, as a real quick little thing, point out that the star Polaris, that's our North Star, is actually a Cepheid variable. Uh, it varies a little bit shorter than most Cepheids in about 4 days. It doesn't vary by very much. It's 0.05 magnitudes. That's really too small to be seen with your naked eye, so you can't just go out and visually look and see, oh, wait, it's getting brighter or dimmer. About the smallest variation that you can see with the eye is close to 1/10 of a magnitude, and even then it's you can really only verify that if there's another star nearby that's similar in brightness that you can see the variation. So you can't see this visually, but it does vary. The interesting thing is that variability was about 1/10 of a magnitude prior to 1963. And the period has been increasing a little bit ever since they first rediscovered that it was a Cepheid variable. And the magnitude has gradually increased in the last 1,000 years. We have records of the star Polaris that go back very, very far, back before it was even the North Star, before precession made it the North Star, and it wasn't all that big of a star at the time. So it's actually been gradually getting brighter, and the period's been gradually getting longer. So what does that mean? Well, we realized that later on that Cepheid variables are actually a type of unstable star that's in the process of dying. So Cepheid may actually be dying and evolving out of its period of variability to actually fully die. That means that Cepheid variables are not really the perfect measuring stick that we would like them to be. There's a reference here to a term called standard candle. And a standard candle is a term that's used to describe something that's you can use to measure the brightness of and put into that distance modulus formula. There are other stars out there that vary. There are some things that we call our Lyra variables. They're very much like dwarf Cepheid variables. They tend to do the same thing the Cepheids do, except they do it smaller, dimmer, and faster. And so they typically vary between 0.1 and 2 magnitudes, and they do it typically in a day or less. They can do up to 2 days, but most of them are less than a day variation. And so that makes them a little bit different sort of thing to study. There's also long period variables. Mira, Omicron Ceti, is a long period variable. And they vary between 2 and 10 magnitudes, and they can take between 2 months and 2 years to do this. Mira itself is a little bit under a year in terms of its variation, and it varies by quite a bit. But imagine, even if a star varies by 5 magnitudes, that's 100 times difference in brightness. And so that's enormous. If you were on a planet surrounding a Mira variable, it would alternate between being super hot and super cold. Basically, life would be uninhabitable. Which is interesting because the star Omicron Ceti was featured in one of Star Trek, the original series episodes, where they had colonists that were living there, and they thought would be dead by the time they arrived. They arrived, the colonists were still alive, and they tried, well, why are they still alive? Because these pod plants were shooting spores, and they shot Spock, and he lost his inhibitions, fell in love with a colonist girl, and then they shot the rest of the crew, and anyway, watch the whole thing, you find out. I mean, sorry, but you got a Star Trek nerd as a professor, so you're going to get an occasional Star Trek reference here. Okay. But what would it be like if you were on a Mira type planet, or planet around a Mira type star? When it's small, it's going to be really hot and very bright. Okay, when it's big, it's going to be cool and not very bright. So it's possible that when it's expanded like this, that the sky will be dark in the daytime and big red glowing blob up in the sky. And when it shrinks, it might get so hot that you'd boil away the oceans. So it would not be a very nice planet to live around. Okay. One of the interesting things we discovered, I used the term instability strip when I was talking about Polaris, and that is on the HR diagram, you get the main sequence running diagonal. Turns out that there is a region in here, and a region that pretty much any star in this part of the HR diagram is going to have that layer in it that is expanding and contracting, and so they will pulsate. So this is what we call the instability strip. And Polaris just happens to be right on the very edge of the instability strip, and it's probably, as it's dying, moving off of the instability strip. And so that's why it's gradually changing. But yeah, any star in that part of the HR diagram is going to be a variable star. Okay. There are other pulsating variable stars out there, RV Tauri stars. I've studied those before. We actually had a project with a student in which she got a publishable paper studying RV Tauri stars quite some years ago. And so these are stars that have multiple layers in them that oscillate, and so they have multiple periods. We have some stars that pulsate with not very regular periods. They don't follow a nice, neat little period. Sometimes they oscillate, 5 months, sometimes 6 months, sometimes 3 months. Sometimes they go 5 magnitudes, 4 magnitudes, 3 magnitudes. Irregular variables, they are also things that don't tend to very, very nicely. Betelgeuse is like between a semi-regular and regular variable. And some of y'all that were watching the news early part of the year might have seen where Betelgeuse was getting unusually dim, and people were thinking, something big thing is going on to it. But a lot of variable star astronomers, myself included, was saying, well, let's wait for a little bit and see what happens, because it is a semi-regular variable. I mean, depending on who you ask, it's either semi-regular or irregular, and it does these like random sort of things now and then. And this may be just one of those random things, and sure enough, it is. And so it started brightening back up again. But these are the different kinds of pulsating variables. And again, towards the early part of this year, it was doing its thing, and then it just like started dropping off in brightness. And people were like panicking about it, but it eventually turned around and it's brightening back up again.